We are back again with yet another fascinating round of Quest, the weekly inter-school science quiz which is brought to you by the National Council of Science Museums and Doordarshan Kendra, Kolkata. And very much the same as last week, we have Mr. G.S. Rautela, who's the director of Nehru Science Centre, Mumbai, who's going to be asking us a lot of very interesting questions. Hello, sir.
Welcome.
Let's give a warm welcome to him. The two teams here, on my right is the J.C. Bose team. That's the team from MP Birla Foundation, and you are?
Hi, I'm Sahana Sen. I'm from MP Birla Foundation and I've been recently promoted to class 12th.
Hello, I'm Abhishek Sharkar and I am in class 12 and I am from the same school.
Hi, I am Sharon Pal from the same school studying class 12. My hobby is to play cricket and a whole lot of games.
Are you all science students?
Yes.
Yeah. Yes, sir.
Any of you want to become scientists in later life?
Maybe.
Maybe, okay. And on my left we have the C.V. Raman team. That's the team from Vivekananda Mission School, and you are?
I am Bhaskar De, a student of class 12 from Vivekananda Mission School, Joka.
Hello, I am Somdev Mukherjee. I am from the same school. I have been recently promoted to class 12.
I am Payal Banerjee. I am in class 12.
Well, we welcome both the teams here today. As usual, this quiz will have a total of 7 questions. The first 4 are direct. They carry 20 points each. 2 directs for each team. 20 points on directs, 10 on passes. If neither team answers, we go into the audience. 15 seconds to answer on your direct questions. Last 3 on the buzzer. And as usual, there will be plus 20 and minus 10. Without wasting any further time, onwards to the very first question, which is for the J.C. Bose team. J.C. Bose team, if you're ready, here comes your very first question.
Well, I would like to know your name first.
My name is Sahana.
Sahana, I have a bottle here which behaves very peculiarly. If I call your name, the water starts falling down. If I say stop, it stops. Rehana, stop. Now the question is, what makes the water fall and what is the scientific principle involved in this?
So basically you have that thumb over that, there is a hole where you are placing the thumb.
Yes,
so when you have the thumb on that hole, there is no external pressure which is acting over the water surface, and so the water is not coming out.
Why on its own weight it doesn't come down?
Sir, because the outward atmospheric pressure, that is enough to balance that weight of the
That
water.
is in fact more than the weight of the water.
sir.
So absolutely right, they get 20 points.
Well, viewers, we hope you remember you're watching an inter-school science quiz and not a magic show here. All the same, 20 points to the J.C. Bose team. Water of India it was, right?
Yes.
Okay. And we'll be back very shortly with the next question. $20 points to the J.C. Bose team. C.V. Raman team yet to face any questions. Here's your first question.
Well, your question is, I have a magnet and I have few pins, so it attracts. Now I put the magnet on the top of this specially made gadget and I put a plywood in between and see whether it, under the plywood, whether it can attract the pins. Yes, it is able to attract, and you can see nicely they are hanging. Now I remove the plywood and put an acrylic or a plastic sheet, see what happens. Again, the pins are attracted. Okay? The pins are attracted. Now, what would happen if I insert this metal sheet? This is a GI, galvanized iron sheet. What is likely to happen and why?
The pins are going to fall down. And
Just see whether they fall down first. You are right. Tell me now, what is the scientific reason?
the galvanized iron sheet is a magnetic substance. It concentrates the magnetic lines of forces inside it. So the magnetic lines of forces are not able to pass through the GI sheet to the pins, and so the pins are not attracted due to induction.
What
And
do you call this process?
this is called magnetic shielding.
You are right, 100%. So you get 20 points for this.
Well done, Bhaskar.
Well, this is the technique they use in protecting very high magnetic substances from magnetic field. For example, television tubes, they have a coating of ferromagnetic substances which doesn't allow magnetic field, because of the fluctuating electrical field inside, to go to the electronic components and spoil them. So this is the technique they use, and you can also save a lot of electronic circuits in other gadgets by shielding the magnetic field by having this ferromagnetic material coating or cover around them.
Well done, you pick up 20 points for your team. Both teams are now tied at the same score, that's 20 points each, as we move into the third question of today's episode. With the scores reading 20 points each, the third question is for the 𝐺𝐶 team.
Well, your question is, I have a paintbrush and water. When I insert this paintbrush inside water, you see the hairs go apart. But when I bring it out, they clinch together. Your question is, why does it happen so? When it is inside the water, the hairs are away from each other. When it is taken out, they clinch together. Would you like to see them? See how the hairs have gone apart? And outside they clinch together.
It happens due to a phenomena called surface tension of the water molecules. When we dip that brush into the water molecules, on account of their cohesive force,
Yes.
they try to move those brushes away, brushes away. But when we pull that out, due to the adhesive force between the molecules of water and air, these are brought together.
Your answer is right, but I would like to correct you. The cohesive force is outside and adhesive force is between different surfaces, the container and the water molecule. Whereas when it is outside, this is cohesive force between the molecules of water. They try, because the surface tension want to come closer, because the hair is very light, so it pulls it in and they get stuck to each other or clinch together. So that's the answer. So you get 20 points for this. Let's give them an applause.
$40 points then to the 𝐺𝐶 team. Next question is for the C.V. Raman team. Welcome back, you're watching Quest. The scores at this stage, 𝐺𝐶 team is on 40 points, C.V. Raman on 20 points. They face their next direct question.
Now your question is, this is a gas lighter, you all know. It gives you a shock when you touch it. Touch your finger. Did you get it? Would you like to test yourself? Put your finger inside, yeah. You got it?
Yeah.
Now the question is, without a battery, how does it produce an electric field?
The gas lighter has a magnet in it. When the magnet is moved, the flux connected to a coil present in the gas lighter changes, and as a result electric current is produced, and so the electricity passes through the outside surface and the inner core of the gas lighter, and thus when we touch it we get a shock.
Well, try it again at home, see whether you can produce such a big potential. Would you like to try? That's not quite correct. Would you like to try?
Just trying it. It is basically we have there are two metal surfaces, and when we are pushing that lighter, due to friction between the two metal surfaces, a spark is produced.
No, why do you get a shock? That's the reason I knew this answer you are going to give me. It's not a cigarette lighter, it's a gas lighter. That's why the shock was there. There is electrical potential developed while you push the plunger.
That is because when the friction develops, there is heat is produced in that metal surface, and from and but the outer casing of that lighter, that is in the atmospheric temperature, and something called Seebeck effect develops, due to which EMF is produced and
No.
current is produced.
Would anyone try from the audience? Yes.
Come. What's your name?
Harshaditya Podar.
Yes, Harsh.
There is a magnet inside the gas lighter. When you push it with the plunger, the magnet moves, and there's a coil as well. Now, because there's a change of flux through the coil of the magnet, through the coil due to motion of the relative motion between the coil and the magnet, a current flows through the coil. As a result, we receive a shock. Because
That's exactly, they gave the answer. That's not right.
No, Harsh, that's the wrong answer. You have to go
Anyone
back.
else would like to try?
Nobody going for that one?
Well, I'll have to explain you this. There's no magnet, no coil, no stone to rub. There is a crystal, quartz crystal inside this. This is called piezoelectric effect. When any crystal is subjected to mechanical pressure along its faces, it develops charge on the top, on two sides. That charge is fed to the inner connector and outside. That's why you get a shock. And that's what produces a spark and lights your gas. That's a simple. So it's piezoelectric effect which happens due to compression of the crystal which is inside this particular gas lighter. And you know where it's applicable? What I would like to know?
Sure thing.
This is used, this technique of piezoelectric effect or utilizing this principle is in recorders. The stylus, when it goes around the grooves of the spool, it produces mechanical vibrations. That mechanical vibration is fed to the crystal and it gives oscillating magnetic electric field. That electric field is able to record in the electronic or a play whatever was recorded in the spool or in the what do you call that?
Long play LP records?
LP
Have
records,
you seen
yes,
those?
you're right.
Or is it way beyond your time? You've seen records?
No, on television.
You've seen records on television? Well, I'm sure when Mr. Rotela and I were little children, all the music that we used to get used to be on records. They had different revolutions per minute, different RPM. We had 33 and 1/3 RPM, 45 RPM and 78 RPM. And the sound used to be transmitted very much in the same manner through a crystal in the stylus, converted into electrical energy, which became sound. Good question there, Mr. Rotela. So scores remain where they were. That is the J.C. Bose team on 40 points and the C.V. Raman team still on 20. The next question is on the buzzer. We'll be back shortly. The next three questions are on the buzzer, plus 20 if you hit the buzzer and get it right, minus 10 if you get it wrong. Remember teams, as always, if you hit that buzzer, you must be ready with an answer, irrespective of whether or not the question has been asked to you. Mr. Rotela.
Well, I have in this flask a mixture of alcohol and water, ethyl alcohol and water. I put this paper inside, soak it in this, and take it out and burn it. See this burns? Could you see the flame?
Yeah.
Now the question is, why does not the paper burn?
C.V. Raman team, Vivekananda Mission School.
The paper is wetted with both water and ethyl alcohol.
Okay.
The water is soaked by the paper, and the ethyl alcohol only burns, and since water does not allow the temperature of the paper to rise above its ignition point, but so the paper does not burn. But the ignition point of ethyl alcohol is much less than that of paper, so the ethyl alcohol can burn, so the paper seems to burn, but the paper does not get charged.
Why does not the paper burn? That's the question.
Because it is wetted with water, and water does not allow the
ignition temperature of the paper to rise.
Yeah, that's right. So they get 20 points, but you should say that water for evaporation takes the heat and doesn't allow the paper to reach its ignition temperature. All right? That's the question. Even if the alcohol burns, it also produces water. Right? Carbon dioxide and water. So that also adds to the paper. Okay, that's the correct answer. Anyway, you get 20 points.
A big round of applause for them.
Well, Gaurav, I would like to do an experiment with you if you have money.
Money?
Yes, a rupee note, I will burn it. If you can dare to do that.
Well, Mr. Rotela, I hope you know that burning any currency is a federal offense.
But, well, I'll see. I'll not break the law.
Is there a money back guarantee here?
Yes.
Let's hope I've got a small note on me. I don't know what this guy is up to. Here we go.
100 rupees. Anybody else would like to? You want to do? Just see.
My money! What's he going to do?
Don't cry. Don't cry. Let's see what happens. Let's close our eyes. Oh, I'm sorry, it didn't burn. So I didn't break the law.
Thank God for that.
Okay, so exactly that's what is happening. As I told you, is alcohol and water. When alcohol burns, the water doesn't allow the paper to burn. Okay?
Well,
so you are safe.
Well, I would say you are safe because you would have gone in at this point. Well, both teams then, 40 points apiece. And the next question again on the buzzer. With the points tally reading almost like a tennis score. 40 all, yes, deuce. Let's see what happens in the next question.
Well, normally you see shadows. What is the color of a shadow?
Black.
Yeah, let's see whether it's black. I have a light here and put a shadow. The shadow looks black. Okay. Now the question is, this time I'm going to change the color of the bulb. It's a white light. So I'm changing the white light into a green one. Now the question to you is, what's going to be the color of the shadow? Or either of the colors. So you have to tell me the theory. I can use any colors here. Red, blue, green, primary colors. What will be the color of the shadow?
Hurry up, teams, 5 seconds to go. I'm afraid we are out of time here. Anyone in the audience?
Yes.
Come up, Milind. Hold the mic.
It will be yellowish red.
Come this side. Yes.
It will be yellowish red, the color of the shadow.
Yellowish red means orange?
Yes.
In case of green?
In case of green.
Well, how did you arrive at this answer?
Because when it was white light, we saw a black shadow.
Yeah.
So in case of green, since the bluish end of the spectrum is being covered up, the yellowish orange end would give the color to the shadow. To the
shadow is, the color is missing light.
Yes. So
shadow is the missing light. So you have removed green from the shadow, from the lighted area.
We have a green bulb there.
Yes.
So the light which is coming out, it is the green light which is coming out. So to remove it, we have the orange end of the spectrum there.
Well, you are getting, yes, you will have blue and red, blue, green, from white taken green away.
Yes.
You have red and blue left.
Okay, red and
blue. So you will be magenta. The shadow, so you are not quite right. Let's see what is going to happen.
When you move back.
See this magenta color?
Move back this side.
You are able to see?
Should I hold this for you?
Yeah, okay. I think I would like to show to these guys. Okay, magenta shadow. We always have the confusion that what would be the, people say light, shadow is the missing light and it should be always black, but it doesn't happen. In fact, this white surface, to add to your answer, is red, blue, green combination. If you look at the triangle, red, blue and green, 3 primary colors. So white has all those. If you mix all 3, you get white color. Now if I'm having green, and blocking green means I'm taking away green from the white light. So what is left is red and blue. Red and blue mixed together, additive color mixing it will be magenta. Now, if I change it to, say, blue, what is going to remain?
Blue and red.
It will be yellow. You are right. Let's see what is yellow or not.
I'll hold this for you.
Yeah. Yellow is going to be very light. No, this side. Yeah. See this yellow color? Okay. And if I change this one to red,
Cyan.
yeah, you are going to get cyan color. Let's see whether that happens. Yes. Okay. So that's exactly the principle of shadow, color shadows. All right. So it is additive sum of two colors taken away that particular color which you are blocking. So from white, if you remove one, so two other colors will give you. If you have all three colors taken off, suppose I had red, blue, green here and block all three, what would you have got?
White.
You would have got, no. You would
Black
have got
shadows.
black shadows. You are right. Okay. Thank you very much. Nobody gets any point for this.
Neither does Milind get anything?
No, he is also not accurate.
Neither team brave enough to go for the buzzer. Scores remain exactly where they were as we go into the last question of today's episode of Quest. We've got the last question in front of you now. Scores 40 points each. The last question is on the buzzer.
Well, the question is, I have a container which has three outlets. And when I am allowing the water to come out of this, you have to tell me which jet will be going the farthest. I keep on filling it up. So there are two conditions when the water is allowed to come through the sprouts, and you have to tell me which will go farthest. But I am maintaining the water column in the tube. Okay.
Lowest.
Oh, sorry.
The water in the middle column will go the farthest because the height of the middle column and the height of the distance of the middle column from the ground is much higher than the lower outlet. So gravity has to take some more time to make the water hit the
Why
ground.
not the top one?
Because at the top one the pressure is very low.
No, I'm maintaining, and why not the bottom one? The pressure is highest.
Pressure is the highest because it can only go a small distance because the height of the water, the height of the fall.
Up to the outlet is quite small, and that at the top it is quite large, and that's why it's going out.
Well, your answer is right, but the explanation is not quite correct. I would like to give you 10, 20 points for this, but the answer is not that. If you look at this, if you look at what plays a role in this is the speed of water coming out of the jets. And according to Torricelli principle, the speed of water that comes out of the jet at any point is √2gh, okay, the height from the bottom, all right, the water column. Now, if you calculate using that velocity principle, the range at which it will reach is maximum for h/2, the half of the tube, all the time. Okay? So the middle, if it were little up, it would not have been correct. It's the midpoint which is very important, and it will be the farthest for this. But you have to keep the water column maintained so that the pressure is all the time same. If you reduce it, then you will find the bottom one goes highest. Okay? So you get 20 points for this.
Stealing a march ahead then is the C.V. Raman team. That's the team from Vivekananda Mission School. Their final score tally reads 60 points. Let's have a big round of applause for them. Well done. Thank you for being on our show. And MP Birla Foundation, that's the J.C. Bose team. 40 points. Big round of applause for them, please. We hope you've had as much fun watching our show as we have had in making the same for you. The final scores, as you know, JC Bose's team is on 40 points, CV Raman is on 60. Do write back to us with your comments, or if your school would like to take part in our quiz, our address, very much the same as usual. Quest, care of Doordarshan Kendra, Kolkata, 18/3, Uday Shankar Sarani, Golf Green, Kolkata, 95. We'll see you again next week with a whole lot of new experiments and new faces. Till then, it's goodbye from all of us.